Hi, my name is Humaira Aryanpot. I'm Bondor Metecno Group's National Technical Manager. As structural engineer by profession, I look after our research and development activities, accreditations, technical support, training, and our NATA accredited structural lab. On behalf of Bondor Metecno, I would like to thank HIA for the opportunity to be part of the NCC 2022 seminar. The images we just saw on the screen are examples of Bondor's insulated panels showcased in a recent TV program called Open Homes Australia. Insulated panels are gaining popularity with innovative builders who are looking for sustainable solutions with modern appearance, with one of the houses we just saw being totally off the grid, which clearly goes over and above the outcomes expected from the changes to NCC's residential energy efficiency provisions. You would be aware that the residential sector is a big consumer of energy. In fact, 57% of emissions from the building sector come from housing and apartments, and 40% of that is related to heating and cooling. But the changes to NCC aim to go beyond reducing the environmental impacts. In recent times, much of Australia has experienced extreme weather conditions, and the ability of our homes to provide comfortable living conditions without fully relying on air conditioning has gained more attention, focusing on improved occupant comfort, reduced energy wastage, and improved resilience to extreme weather. And these were the subject of several studies conducted by the Queensland University of Technology from 2012 to 2015. And in the next 5 minutes, I would like to take you through some of their findings. This first study looked at 15 traditionally framed homes. In trying to identify potential problems with the current building practices, thermal imaging was used to look at how the insulation was installed. Most of the houses studied displayed issues, which highlights that one thing is to get the regulations right, the other is to come up with solutions that offer reliability of the outcome in practice. The study concluded that the thermal performance of a building to a great degree depends on the quality of the install. Here we're looking at some of the thermal imaging from this study. We can see missing insulation, poor perimeter coverage, and leakage around doors and windows. And 2 of the homes out of 15 revealed extensive non-compliance issues that had to be resolved by the builder. And when we're considering the overall thermal performance of the building, proper installation of insulation does matter. To demonstrate this, QUT used the NCC table for compensating for loss of ceiling insulation to work out the reduction in R values due to missing insulation. For example, depending on what R values you're aiming for, taking away just 10% of the insulation will reduce your R values by a staggering 53 to 76%. And this led to another study, which looked at 5 houses made out of insulated panel, built by 5 different builders for 5 different clients in 5 different climate zones. Clearly, being made out of insulated panel meant that the insulation was continuous, but each house was subject to a blower door test, infrared scanning, and smoke tracer to check the effectiveness of thermal and building sealing. And overall, the study reinforced that using SIPs ensures a reliable outcome, and that the lack of experience doesn't affect the thermal performance. And because we have continuous insulation in the walls and ceiling, the main area of thermal loss is through glazing. They're quite airtight at 2 to 9.6 air changes per hour, compared with the traditional houses tested by CSIRO showing 1 to 39 air changes. Hence, this study identified that SIPs do have a role to play in the residential sector in resolving insulation and airtightness issues. And this led to yet another study. In the first study, we highlighted some problems with the way we build houses in Australia. The second study showed that not only at the design stage or theoretically, but also at handover, we can expect massive improvements by utilizing SIPs in housing. But how about the living experience? This is exactly what the next study looked at. This house was built entirely out of insulated panel. The house was designed for panel, taking advantage of the large spans and raked ceilings, and we had a family of 4 living in it for a year. This is showing the difference between a 9-star home as designed and what was actually achieved during the 12 months of occupancy. The house was modeled in BEAR's software as a conditioned house, and as a 9-star home, you'd expect to be within the comfort range of 18 to 28 degrees, 92.5% of the year. The second bar is showing it modeled as a free running mode, hence no air conditioning, and you would expect to be in the comfort range 87% of the year. But in fact, during the 12 months that the house was being monitored using some air conditioning, the occupants chose to be within the comfort range 96.5% of the time, and this is with minimal use of air conditioning. This equates to 9.5 stars. This is showing the temperature fluctuations on a winter day and a summer day. The yellow line is showing the outside temperature, which was measured through a weather station that was located on the roof of the house. The blue line is showing what is expected through BEAR's modeling for a 9-star home, and the red is showing the actual temperatures. As the red lines demonstrate, we have a well-insulated house with minimal temperature fluctuations that is cooler in summer and warmer in winter. A point worth highlighting here is the stakeholders' influence. The graph on the right shows that in summer, the occupants could have opened the windows overnight to ventilate the house and take advantage of the cooler outside temperature, which would have then dropped the red line to temperatures within the comfort range the next day, further reducing their reliance on air conditioning. And the overall results using the insulated sandwich panels were quite impressive. Their electricity consumption was 48% less than Southeast Queensland. Even by using air conditioning to get to 96.5% comfort level, only 13% of their energy was used for cooling and heating. This compares to a national average of 39% at the time of study. As mentioned before, the house was modeled as a 9-star, but achieved 9.5 stars in occupancy. With a high level of comfort, with minimal space heating or cooling. They achieved net zero for space heating, cooling, lighting, and most water heating using a 2.1 kilowatt solar system. A typical 5 kilowatt system would have achieved a total net zero. And as mentioned, this was achieved by first-time users of this product, demonstrating that insulated sandwich panels are reliable, affordable, and sustainable solutions that meet and exceed the new thermal performance requirements of NCC. They provide comfortable living conditions and are suitable for Australia's extreme weather conditions. I would invite you to visit Bondor's website for more information. You can also download an ebook of this presentation from our website or by clicking on the link below on this page. Thanks for your attention.